Hey everyone, it's John again. Today I'm going to do a video on root redistribution, and it's between EIGRP, RIP version 2 and OSPF. You can see the networks here. I've got EIGRP autonomous system number 13, a RIP version 2 network here and here, and on the right hand side we're going to go with OSPF. Now, the IP addressing is a bit random. I've just changed it up so it's not just your basic /24, so some /17, 16, 8, sorry, /29, and a /28 up here. And just for full kind of connectivity and for testability, should I say, router 1 has been configured with a loopback, as has router 5. So yep, that's it. So let's just get started and go for it. First thing I'll do, I've actually put all the IP addresses on these things, so you can see the show IP route. You've got all the connected addresses. So let's just start and configure the actual routing protocols. So we'll do a conft, and the first one we'll do will be router EIGRP, and the autonomous system number we're using this time is 13. Okay, now we'll do an EIGRP router ID, and we'll just make it all the ones. And we'll do a no auto summary, so we're not doing auto summarization. And the network address is going to be, as you can see here, we've got all the ones, which is a /32, so our wildcard mask, or the inverse of that, so it's going to be a 0.0.0.0, and that is that. And the network is the 200 network here as well, so we've got 200.0.0.0, and it's a /28, so that's going to be a wildcard mask of 0.0.0.15. The way I do that is basically /28 are going to be in block sizes of 16 minus 1 from it. It's a quick way to do it, so you've got a 0.0.0.15 network. Okay, so next one is R2. You can see here we have the 200.0.0. network, as well as the 150.0.0.8 network. So let's just configure the EIGRP on that first. So router EIGRP, and the autonomous system number again is still 13. And we'll do EIGRP, router ID, all the twos. And the 200 network up here is going to begin into EIGRP, and the 150.0.0.8 will be a redistributed RIP network. So we're just going to configure the EIGRP as the 200 network. And our wildcard mask again is 0.0.0.15, and we should establish our adjacency. There we go. So show IP EIGRP neighbor, and we'll do a show IP root. And as you can see here, our actual connected network, the 200 network, is still shown as just a connected, obviously, because the administrative distance for network, the 200 network, is basically 1 versus the 90, which would be EIGRP, so we're not seeing that via dual. However, we can actually see the loopback because that's not directly connected in effect. So EIGRP is up and working. Let's go and configure the RIP version now. So we'll do router RIP, and we'll use version 2 because nobody likes version 1. And we'll do no auto summary for no auto summarization. And the network we're going to be doing is 150.0.0.8. Don't need to do wildcard mask because it's just basic RIP, and that's that one there. So let's kick on, and we'll go to router 3. Right. So same here. As it turns out in this one, both of the networks, the 150.0.0.8 and the 150.0.0.16, are both going to be RIP networks, so we can just batter on ahead and just fire them in. So router RIP version 2, no auto summarization, and we'll do network 150.0.0.8 and network 150.0.0.16, and that should be that up. And that's what's done for router 3. Now router 4, this is going to have an interface, or rather a network. The 150.0.0.16 will be in will be a RIP network, should I say, and on the right we've got a 135.0.128.0. That is going to be a OSPF. So let's just kick on and do that then. So we're going to do conft router rip version 2, and the network will no auto summarize that first, and the network is going to be 150.0. Oh, is that not coming up? Yep, 0.16. Right, so that's that done. And now we're going to do OSPF. We'll use a process ID of 1, and we'll make the router ID all the 4s to match the actual router number. And we'll do the network will be 135.0.128.0. So the network, the wildcard mask will be 17. So that's a block size of 128, so we take 1 off at 127, so we'll have a network, or rather a wildcard mask of 0.0.127.255, and we're going to pop that into area 0, and we'll control C that, and let's move along to the final router, which is router 5. We'll show IP route that. Okay doke, and all interfaces are going to be getting into OSPF, so let's go for that. OSPF 1, router ID, we'll make that all the 5s just for keeping the same format, and the network address we'll do 135.0.128.0, and again the same wildcard mask is 127, and it's all in area 0, and the network will be all the 5s for the loopback, and we'll also make that area 0. So we'll show IP OSPF neighbour, and it's still in two-way state. Give it a wee second and it will go to full. Any minute now. Still two-way. Yeah, there we go, took its time there. That's us now, we're now in the state of full. So that's all up and running, so let's do a show IP route. Now you'll notice here, what do we see? Nothing but connected links, because the only network connected or learned is the 135.0.128, which is this network here. And we don't have a loopback to learn. Now conversely, on router 4, you will actually see an OSPF route, because you'll actually see the loopback address learned. The 5. So we've got a OSPF route here, we have a RIP route but no EIGRP route. So essentially router 5 can see this, router 4 can see this network in the loopback as well as the RIP networks, but it can't see EIGRP. Similarly, up to router 1, you'll notice that all we have are connected routes. So what we need to do is see these routers here. These are ASBRs because they're essentially autonomous system boundary routers. They essentially route between two different networks. This one routes for OSPF, and this, not two different networks, two different routing protocols, should I say. R4 is routing using OSPF and RIP version 2, and R2 is routing with EIGRP and RIP version 2. So what we want to do is essentially redistribute EIGRP into RIP, OSPF, and back and forth. So we'll go to the actual ASBRs, which in this case the first one is router 2. And what we need to do is go into router EIGRP with the autonomous system number, which is 13. And what we want to do is do redistribute, and we are redistributing RIP, and the metric we're using. Okay, now you need to put through your basic K values here, which is your bandwidth, your delay, your load, MTU, reliability, so on. So you can change these, but just for kind of posterity, I'll just use kind of generic values. For bandwidth, we'll have 1544. Delay, we'll go with 10. What will we go? We'll just do 255 here. And 1, and we'll call it 1500. These are kind of generic values that you can use. So that's that. Okay, doke. So what have we done here essentially? So if we go to router 2, and it's the same. but router 1 has now learned RIP routes via EIGRP external, as you can see here with the 170 AD, which denotes external, as do the EXs. However, we've only done it one way. We've not actually redistributed EIGRP back into RIP. So we'll do router RIP, and we'll do it the other way now. So we'll redistribute EIGRP, and the autonomous system number is 13, and the metric is how many hops we're going to be doing, because it's RIP essentially, it's translating to. So just do 2 hops, and that should be that. So now, if we go show IP route, we've got RIP and EIGRP. Similarly here, that's still the same. So what we need to do now is go into router 4. Router 4 again is ASBR. It's going to redistribute OSPF into RIP and RIP into OSPF. So let's just start and do that now. Conf T, and we'll do router OSPF, process ID is 1, and we'll redistribute RIP subnets. That'll pop RIP in, and if we do a show we go to show IP route, we're now learning all these RIP routes as E2 routes, which are external routes. So now we actually can see the loopback, which is initially an EIGRP route, which is being redistributed into RIP, and RIP is therefore further redistributing it into OSPF, so we can now see it. However, if you are looking from the point of view of, say, R3, are you going to see the OSPF routes, the loopbacks? No, you're not, because OSPF has not been put back in to that. Similarly, despite the fact that R5 can see the loopback of R1, can R1 see that? Well, of course it can't, because it's still not got the OSPF to come back into it. So it can't see the loopback. So to get that to happen, we still need to do it the reverse way. So back into, and what we want to do is do a conf T, configure terminal, we'll do router RIP, and now we need to redistribute OSPF, and the process ID is 1 we're using, and the metric, how many hops, we'll do 2 hops again, Control C. If we go to router 3 now, we should be able to see that loopback of the 5.5.5. There it's there. It's learned via RIP. It's actually learned via OSPF translated into RIP. And similarly, up here, we'll now be able to see 5.5.5, the loopback of router 5 from router 1's perspective. There we go there. It's learned via external EIGRP. There's the AD there. But it's actually been learned from OSPF through RIP, translated back to EIGRP, and let's just test the connectivity in that. So all the 5s, yep, no bother at all. Similarly, if we go to R5, of course the ping went back, so it's obviously can connect, but just we'll do it anyway. And we'll do show IP int brief, and we'll exclude the unassigned. And the IP address is 135. We'll just ping that there as well. So we'll ping 135.0.255.254, and let's see if we can hit router 5's actual interface. That's us, we'll get full connectivity, and yep, that's pretty much the end of that video. It's quite a short one and simple. All you need to do really is to remember, some people make the mistake of configuring such that you translate from one routing protocol from OSPF into RIP and forget to do it back, so you don't actually get the return ping, so you can't get full connectivity. So yep, that's pretty much the end of the video. It's quite straightforward. If you're having any issues, just practice makes perfect pretty much. Just do it a few times and you'll see it's not so hard. So that's the end of the video, and I'll see you guys soon. Thanks, bye.